Okay, hey guys. I'm gonna try to make this video again. I filmed it yesterday, but my GoPro was a little bit raised too high, and you only saw like half of what I was doing. So it was a long video, but I have to remake it. So let's try this again. Okay, so I want to give you guys a lesson today on boomerangs. So I have a whole bunch of boomerangs here. Okay, these are my favorite. These are called the moguls. Okay, so we use these two templates to make them, and I think they're easy to make and they fly fantastic. They have the highest rate of success, in my opinion, from the ones that we've tried. The next boomerang that we have is called the Easy Throw. Okay, it's a smaller one, doesn't require as hard of a throw. You actually can't throw it hard, or else it flies. It comes back right over your head. Behind you. So this is if you're not a good thrower, you could try to make this one. We've got the big Dream Moon. This one I'm still practicing. It's not the best flyer so far with my throw. Maybe you guys can make it fly good. This is a Lazy 7. This one is supposed to kind of go really far and looks like it's not going to come back, but then it eventually starts coming back to you. And then this one is supposed to be like a semi-record holder, the Janetsky airfoil. So this one is supposed to be a long distance boomerang. So, but again, I haven't been able to get it to work well. So maybe you guys will be able to do that. So why do boomerangs come back to the thrower? Okay, why don't they just fly straight like a piece of wood? So I'm gonna give you guys a little science experimentation here. So I have a ping pong ball and a funnel, okay, and I'm gonna come over to the compressed air here, and I have compressed air coming out of this nozzle, and what I'm gonna do is I'm gonna put the compressed air under inside the funnel here. I'm gonna pull the trigger, and I want to see what you think is going to happen. Okay, is the ball going to shoot out, or is it going to do something else? So here we go. Ready? It's not shooting out. Okay, it actually defied gravity. Somehow it stayed stuck inside there. All right, so we don't know why that happened, but we're making an observation. Okay, and here. That was a bad example. Let me just fix that. Okay, figures I lose my ping pong ball on this video. All right, let me pause this. Okay, let's try this again. So, all right, you guys get the idea, right? Okay, so in the funnel, the ball doesn't shoot out. Outside of the funnel, I can suspend it with the compressed air. Okay. So what's happening? Well, the only difference is the speed of the air. So this is an example of Bernoulli's principle. Okay, so over here we have high-speed air that was coming out of the nozzle, and believe it or not, that created a low-pressure zone. High-speed air creates low pressure. It's the opposite. It's easy to just remember they're opposites. Low-speed air, the air all around us right now, is actually high pressure. This is called Bernoulli's principle. Okay, it's a physics principle. So here, what I have is the cross section of a wing. So if I took an airplane, okay, so let's say here's the front of the airplane, right, and then you have the tail. Okay, say something like this. Here's the cockpit. and then all the windows. So this is called an airfoil. Okay, the shape of a wing, the cross section of a wing is called an airfoil. I'm going to be using those terms, wing and airfoil, together. So let's say that this plane had a propeller in the front of it here. It could have jet turbines underneath it, you know, or jet engines back here. When this plane starts moving through the air, okay, the air is going to hit the front of the wing, and some of it is going to go above the wing, and some of it is going to go below the wing. So this shape actually causes the air to move at different speeds. Because of the front, the leading edge here, and the trailing edge, the air above here actually accelerates. Right around here, if you were to put this wing in a wind tunnel and put a little bit of smoke in front of it, you would be able to see that there's these little tornadoes over here, this turbulence, and it actually sucks in the air over the wing here. The air that goes underneath the wing, it's just moving normally. Now this whole wing is moving through space you know, it's moving through here, but what's happening is that if you were to unfold the top half of the wing, right, all this line from here to here is longer than this line. This is a straight line. Here I gotta go up, over, and then all the way back down. This is just down and straight across. This is a longer line. So the air above the wing is actually traveling at high speed. Okay, it's traveling faster than the air below the wing. This is low speed. Well, if we look at Bernoulli's principle, low speed air creates high pressure. High pressure. Okay. High speed air creates low pressure. Which way is the high pressure going? High pressure is going upwards here, okay? So pressure is going this way because there's a low pressure zone above it. Guys, this phenomenon is called lift. And this is how planes fly. This is why when the plane turns on its engines, you're sitting on the runway, and it starts moving, okay? And then it starts going faster and faster, okay? It starts accelerating. Once you reach that specific velocity, you're going to create so much lift that it's going to be able to raise the plane up in the air and lift all the people and all the cargo and the weight of the plane. You know, hundreds of tons of weight, okay, we can just do by generating lift because of this shape. You probably have noticed it if you take your hand and you put it outside the car window, and right now this looks like a wing. It's a cross section. And you can just change it's called the angle of attack, okay, the angle of the wing, and you can actually feel that you can generate lift and go, you know, downwards lift, upwards lift, okay. If any of you have boats and the tiller, so you have your outboard motor, right, and on a boat, and then you have the propeller on the back of the motor here, and then you probably have two little wings right here. Those are called hydrofoils, okay? Not an airfoil, a hydrofoil. And if you change the angle of attack of these hydrofoils, they can generate lift. And what do? They lift the front of your boat up or down into the water as it's traveling through the water, okay? You can adjust those. And then lastly, where do we see these wings? Well, obviously they're in nature, okay? If you had a glider, like a glider plane, the glider would get towed by another plane, and then they disconnect the tow cable, and the glider can actually just float through the air, and it's generating lift because if the wind is correct and if it's moving, it could generate lift without any power. The glider just glides. And then on the back of cars, okay, so here's a car. Where do you see a wing? On the spoiler. So on the back of a car, you would just flip this shape like this. Why would you want a wing on the back of a race car, okay, well, if you flip this airfoil upside down, you're going to create lift, but it's going to go downwards. You can add more traction, more force on your tires. So you could build a very light race car with a big, powerful engine, and then if you go fast enough, you could make these tires feel like they have hundreds of pounds of weight on them, but that's just caused by the downwards force of this upside down wing. Formula One race cars, if you ever look at them, all they are is just a massive wing that's upside down. So those little light carbon fiber cars can drive 200 miles per hour and take turns, super sharp and not fly off of the track because they're generating so much downwards lift. What does this have to do with boomerangs? Okay, so if I go and I look at a boomerang here, so this one, you can see that here is the trailing edge, the back of the wing, and here's the rounded leading edge. Okay, same thing here, trailing edge, leading edge. What this means is that when I throw the boomerang, well, basically, if the boomerang is spinning like this, it's going to generate lift like a helicopter propeller. So it's going to go straight up. Once this starts spinning, it's going to generate lift, and you're going to have low pressure above it, high pressure underneath it, and it's going to fly upwards like a propeller. That's not how you throw a boomerang. You actually throw a boomerang like this, vertically, at a slight angle. And so the lift then is generated sideways like this. It spins and it goes sideways. So why, when you throw it, does it not just go sideways all the way across, like so? Well, there's another phenomenon we have to look at, and I'll show you here. I could demonstrate it with this bicycle tire. Okay, so if I have this bicycle tire and I lay it flat right here, it lays flat, okay? This string is mounted onto the axle of the bicycle tire. Now if I start spinning it, okay, the bicycle tire wants to stand upright perpendicular to the rotational force. So it wants to be 90 degrees onto that axle of the rotational force. You guys know this, that once you stop riding your bicycle wants to fall down. Once you start moving, it's very easy to just stay upright, okay? But once that rotational force stops, okay, you wind up, the bike falls down. Guys, that's called gyroscopic precession. Gyroscopic precession. Oops. Precession. Okay, so what that is, it's a self-correcting force on a rotating object. So if the object is rotating this way, okay, it's going to be standing upright, perpendicular to its axis, just like a bicycle wheel. What does that have to do with boomerangs? Well, I'm going to draw a top view. So here I am. Here's my nose, okay? And I'm going to throw the boomerang. So I throw the boomerang, and it's spinning. It's generating lift sideways like this, right? And then it goes a little bit more this way, it's still generating lift. Because of gyroscopic precession, if the boomerang were tied to a string and mounted to a pole, it would go in a perfect circle and come right back to me, okay? Because it's going to just generate lift this way. But since it's not tied to a string, it's going to start going like this, like this, like this, like this. And eventually what happens is the boomerang actually then starts laying down, okay? And it slowly lays down. It wouldn't be fully laid down right here. It starts laying down right about here, okay? Really, it would be right over here. So it's starting to lay down, starting to lay down, and then it lays down. And now it's spinning flat. And what we said is that when it spins flat, it actually generates lift upwards. And so this is what allows it to come back to you in a nice floating fashion. So basically, when you throw the boomerang, it's gonna go like this, and then it's gonna start laying down, okay? And then it goes right over here. It just keeps on spinning, generating lift, and it should just float right back to you. It's really easy to catch, okay? And that's what makes the boomerang come back. It's a combination of lift and gyroscopic precession, okay? That's what you need to know. The boomerang comes back to the thrower because of lift. The airfoil creates lift, and then it starts self-correcting because of that lift due to gyroscopic precession. And then once it lays flat here, it's generating the lift to stay aloft and come back to the thrower. Like just make it back to the thrower and defy gravity. So that's how boomerangs work. So what you're gonna do is you can research a design, make your own design, or you can use one of my templates. So like I said, I can basically, if you make this boomerang perfect, I can guarantee you that it will come back to you if you throw it correctly. So we have the exterior template for the shape of the boomerang, and then we have the airfoil template where you trace onto the boomerang like this, and you have to then sand and shape the airfoil from this edge to this edge. I'm going to show you how to do that now. Okay, I'm going to try to make this video a little shorter, okay, than the last one. So I'll just show you how to trace the boomerang. Okay, so I have a piece of, by the way, we're using 5mm Baltic birch plywood. I don't know if you can see here, but it's some really nice plies compared to the thicker regular plies here. Okay, you can see there's knots in here. These are thicker. They're not as, we wouldn't be able to, obviously it's too thick, but if there was just 2 plies in here, this wouldn't be good. Here we have 1, 2, 3, 4, 5 plies of all hardwood and of birch, and this is a really great product. It's not going to split. It's going to be very easy to shape, and this is what a lot of people use to make boomerangs. So I'm going to take my template. I'm going to hold it down nice and straight. I'm going to trace it. Okay. Then I'm going to take the. This is for righties. If you're a lefty, you have to have me trace your template for you. So then I'm going to look at the template here, take the airfoil template, and you can see here I'm about a 1/4 inch away, 1/4 inch away. I'm going to match that. So I'm going to line it up on here to make it look just like mine. Okay, and I'm going to trace this really well. All right, I missed that spot right there. I'll just realign and then retrace right around that corner right there. Okay, this was my first one. I then made the new ones with the laser cutter, okay, and they came out really good, but that old template is fine. Okay, so when you go to the bandsaw, there's only one relief cut you need to do. It's this one right here, okay? This inside, that's the relief cut you have to do. The rest you can do in one cut. One word of advice here. Guys, stay about 1/16 of an inch away from the line. Like, cut like that, all right? Leave the line, and then you can sand down to the line. If you cut right on the line, I can guarantee you your wing is gonna be thinner, okay? Your airfoil is gonna be thinner, and it's gonna be less efficient. It's not gonna fly as well. Okay, you wanna be able to get the most work out of that wing. So, just gonna come in here, make my relief cut, okay? And I'm not gonna do this on the video because you guys know how to bandsaw, but I'll show you how far away to stay from the line. I'll say like right about there, it's good. And then you can come back here, you can go like this, you can cut this off and just finish up cutting on the bandsaw, but you want to leave that amount. That'll be good all the way around, okay? So I have one that I started on the old video here, okay? And you can see what I was doing is I was trying to sand the, this is called the trailing edge. So what I would do for you guys, what I've learned is that you guys like to label them. So here it says slope, okay? Sloped. So this is going to be a slope, and then this is going to have an R. This is for rounded, okay? Rounded edge. Again, I'll show you right here on the completed one. Okay, so this one. Okay, sloped, rounded. Sloped, rounded. It's kind of, it's not, just think of it this way. When the two lines are far apart, it's going to be sloped. When they're close together, it's going to be rounded. Okay, so how do we sand this? We're going to be using a drum sander. So I have one on the drill press here. Okay, so I'm going to turn it on, and you're always going to just sand on the left side. If you sand on the right side, when it's spinning clockwise like this, it could push the wood right out to you. So I'm going to turn it on. Okay, and to do the slope, you're going to put your hand right in the back of the area where you're sanding, and you're going to hold it almost parallel. Okay, the goal is to get this line to meet the second ply. You don't want to bring it down to a knife's edge, or else it's going to be too weak and it's gonna splinter. So just go like this. This has got a 60 grit sandpaper on it, so it's really aggressive. Okay, keep it moving. If you stay in one spot, you're gonna get a huge divot, okay? So just keep on checking it. Use the whole height of the drum. All right, look how quickly I just did that. Okay, I'm always checking, so I'm getting close to the edge here. You can see I'm at a good height here. If you want, you could do a quick, slight back sanding, but do not sand the back, okay? This has to be flat, so I'm just gonna go, okay? And now I can see the edge a little bit better. So I'm getting close, still a little bit thick right there, and I gotta bring that up over there. Okay. You want it to look like if you were like canoeing down a river where you could see the sediment layers on the edge of the river, where you see like sand and then clay and then rock and then, you know, another layer, lava. Like that's what you want it to be, nice and smooth. You can see here there's a little bump here. I would sand these two edges out a little bit. Just take it a little bit more. There, nice and smooth, okay? And then for this, so then on this side here, sorry, I want to do rounded. How do you round it? You're just rounding this corner, this top corner. You're trying to do a quarter of a circle, okay? Do not round the bottom, you'll ruin it, okay? So right here from this line to the middle ply. Go to 45 and then roll it. Like this. There we go, nice and rounded. I could do a little bit more. And then roll it. And I'll do here. A little bit more. Okay, this is the tough part where you go from rounded to sloped or slanted. Leading edge to trailing edge. You gotta go like this, then transfer it over. So, kind of like a rail slide. You just kind of go like this. Getting there, okay, a little bit more here. Okay, I'm gonna just be careful. Take a little bit more right off there. Okay, I would get that edge a little bit better. Okay, I'll just do a quick little back cut so I can see. And now you can see here that I'm sloped and I'm rounded. I gotta take this rounded edge more. And this is all you're doing, just light sanding, inspecting. There we go, bring it back a little bit more. And then eventually, we're gonna take the palm sander with 100 grit, and then we're gonna go 220 and do our finish sanding. But you can see I did almost I did a third of my boomerang. This part right here was not done. This was done yesterday. And that took me probably less than, that took me about 5 to 7 minutes. Okay. Guys, that is it. Okay. Oh, inside here, let me show you this. Let me just show you this one last step here. How do you sand inside here? I'm going to use the lathe. I'll show you on the lathe here. Same drum, just it's mounted on the lathe. Okay, we're going to be sanding this at about 1,000 RPM. Okay, just go underneath it like this. Okay, and you can get right in there, and then we'll just do hand sandpaper in there. Okay, do not sand this on the top. It's gonna kick out at you. Always just take your boomerang and go on the bottom, okay? Just like this. Roll it, okay? This drill press needs a new switch. I'll be getting that very soon, any day now. And then here on this lathe, same thing. Okay, you can just go underneath. Okay, and then here I can round. All right, and just keep on rounding. And then we can take a palm sander and get it nice. Guys, that is boomerangs, okay? Hope you enjoyed the video. Can't wait to go throwing with you. And I'll make a video on how to throw them correctly, okay? So, thanks for watching. See you later.